Have you ever wondered if time could flow in the opposite direction, just like your reflection in a mirror? In our day-to-day lives, we take the flow of time for granted. It's a constant, unidirectional force, always moving from the past to the future. We wake up in the morning, spend our day working, playing, learning, and then we go to sleep, only to repeat the process the next day. This perpetual forward motion is so ingrained in our existence that it's hard to imagine it any other way. But what if time didn't have to be so linear? What if, just like in a mirror where left becomes right and right becomes left, time could flow in the opposite direction? This is the concept of a mirror universe, a parallel reality where time might flow from the future to the past, instead of the other way around. It's a mind-boggling idea, isn't it? But before we delve into this intriguing concept, let's talk about a fundamental principle that governs the direction of time's flow: entropy. Entropy, in its simplest definition, is a measure of disorder or randomness. In our universe, the natural progression of events leads to an increase in entropy, creating what we call the arrow of time. From the melting of an ice cube to the burning of a star, every process we observe reinforces this principle of increasing entropy and consequently the forward flow of time. But in a mirror universe, could entropy decrease over time? Could a shattered vase reassemble itself, or a burnt-out star reignite? The arrow of time as we understand it would be flipped, leading to a reality that is both fascinating and perplexing. Imagine then a universe where time flows backwards, a mirror universe, but how would that work? Join us as we dive deeper into this enigma in the next part of our exploration. In a mirror universe, time would appear to flow in the opposite direction, a concept known as time inversion. Now let's break this down and make it a bit more digestible. Imagine you're watching a movie, but instead of running from start to finish, it's playing backward, from the end credits to the opening scene. This is a simple way to visualize time inversion, but let's take it a step further. Picture a glass shattering on the floor. In our world, it's a one-way street. The glass breaks and it stays broken. But in a mirror universe, under time inversion, you would see the shattered glass pieces serenely lift off the ground, coming together to form a whole glass once again. It's a process that defies our understanding of time's arrow, which always points from the past to the future. Now you might be wondering, how would the laws of physics work in this mirror universe? Well, they would be inverted just like time. For instance, the second law of thermodynamics, which states that the entropy or disorder of an isolated system will always increase over time, would work in reverse. Instead of moving towards chaos, systems would evolve towards order. It would be a world where broken eggs unscramble themselves and spilled milk gathers back into the glass. At the quantum level, particles and their mirror counterparts would have reversed charges and spins, leading to an entirely new understanding of quantum mechanics. Yet despite these inversions, the fundamental symmetries of the universe, those beautiful mathematical balances that govern the cosmos, would remain intact. It would still be a universe governed by laws, albeit mirrored ones. So in this mirror universe, everything we know about time and physics would be inverted. But what does that really mean for us? Living in a universe where time flows backward might seem unthinkable, but it could have some surprising implications. Let's start by visualizing the implications of time inversion on a fundamental level. If time were to run backward, cause and effect, as we know them, would be reversed. This means that the effects would precede their causes. For instance, imagine a glass shattering before it hits the ground, or a raindrop ascending to the cloud before the cloud even forms. The very fabric of our reality, built on the foundation of cause and effect, would be turned upside down. This reversal could challenge our understanding of reality. Would we still perceive events in the same way? Would our memories now be of the future and our anticipations of the past? The mind boggles at such a prospect, and yet it is a fascinating thought experiment that pushes the boundaries of our understanding. But it's not just about the mind-bending thought experiments. Time inversion could also have practical implications. For example, it could revolutionize the field of quantum physics. If particles could move backward in time, it might offer new ways to solve quantum entanglement, one of the greatest mysteries in physics. From a philosophical perspective, time inversion raises profound questions about free will and determinism. If the future influences the past, then do we have control over our actions? Or are we merely puppets dancing to the tunes of time? And what about the concept of entropy, the measure of disorder in a system? In our universe, entropy always increases with time, leading to the eventual heat death of the universe. But in a time-inverted universe, would entropy decrease, leading to a big crunch? So time inversion could change everything we know about reality, but is this just a thought experiment, or could it be possible? We'll delve into this in the next scene. For now, let's sit back and marvel at the astonishing possibilities of a universe where time flows backward. Indeed, the implications of time inversion are as perplexing as they are fascinating. While the idea of a mirror universe might seem far-fetched, there is some scientific evidence that suggests it could be possible. Let's delve deeper into what this evidence is and what it could mean for our understanding of the universe. For starters, we've observed anomalies in the behavior of certain subatomic particles. These peculiarities, like the unexpected oscillation of neutrinos, could hint at the existence of a mirror universe. Neutrinos are tiny, ghost-like particles that rarely interact with matter. Yet they have a habit of flipping between three different types in a process known as neutrino oscillation. Some scientists believe this could be a sign of a mirror universe where time runs backward. Now, this isn't an open and shut case. Science is all about testing, questioning and retesting, and that's exactly what's happening. Researchers around the world are conducting experiments to explore this idea further. One such experiment is underway at the Oak Ridge National Laboratory in the United States, which is investigating whether neutrons can transform into mirror particles. But what does this mean for our understanding of the universe? Well, if a mirror universe does exist, it could lead to a paradigm shift in our understanding of physics. It would mean that our universe is not alone, and that there are other universes out there, possibly many, where time might run backward or at a different pace, or even in a completely different direction. This could also have profound implications for our understanding of time itself. If time can run backward in a mirror universe, then our traditional linear understanding of time could be fundamentally flawed. It could mean that time is not a one-way street but a multi-lane highway with traffic flowing in different directions. So while the existence of a mirror universe remains a theory, it's a theory that could change our understanding of time and the universe itself. Time inversion and the mirror universe are fascinating concepts that challenge our understanding of reality. We've journeyed together through the enigma of time, exploring its fluidity and subjectivity. We've pondered the existence of a mirror universe, an idea that seems more science fiction than fact, yet has empirical evidence supporting it. We've delved into the concept of time inversion, a phenomenon where time could potentially flow in the opposite direction. Imagine a world where yesterday is tomorrow, and the future is the past. We've also examined the implications of such a scenario, the profound effects it could have on everything from physics to philosophy. This journey has been a challenge to our preconceived notions, a testament to the beauty of scientific exploration. So as we wrap up our discussion, let's keep our minds open to these mind-bending possibilities. So next time you gaze into a mirror, remember, it might not just be your reflection looking back at you, but a whole other universe where time flows backward.